Two four-way switches can be used in a series. This configuration provides control of a light fixture from several locations. Each standard switch has two positions, typically labeled on and off, and each three-way switch has three terminals labeled line traveler 1 and traveler 2. When implementing this kind of circuit, safety is of utmost importance. Always turn off the power at the circuit breaker before working with electrical wiring. Confirm the power is off with a non-contact voltage tester. You will need several items to do this job properly. Firstly, you will need two four-way switches. A three-way switch is optional depending on the application. Secondly, you will need electrical cable. 14 or 12 American wire gauge, or AUG, is commonly used. Thirdly, wire connectors are necessary. Fourthly, you will require a screwdriver. Fifthly, electrical tape is required for safety. To start, identify the power source. Determine which switch location will receive the incoming power, known as the line wire. Once identified, connect the line wire to the line terminal on the designated switch. Now, connect the traveler wires. Connect one traveler wire from the power source switch to the traveler 1 terminal on the first four-way switch. Next, connect the other traveler wire from the power source switch to the traveler 1 terminal on the second four-way switch. Next, connect the remaining traveler wires. Connect the remaining traveler wire from the first four-way switch to the traveler 2 terminal on the second four-way switch. Then connect the remaining traveler wire from the second four-way switch to the line terminal on the three-way switch if one is being used. If a three-way switch is not being used, connect the remaining traveler wire from the second four-way switch to the line terminal of the last four-way switch in the series. Now connect the load wire. The load wire runs from the switch to the light fixture. Connect the load wire to the common terminal on the three-way switch if it's being used. If no three-way switch is used, connect the load wire directly to the line terminal on the last four-way switch. To secure the connections, cap all wire connections using wire connectors, twisting them tightly. Then, wrap each connection with electrical tape for added security and insulation. Remember, a three-way switch is optional in this configuration. If one is used, it must be installed at the end of the series, between the last four-way switch and the light fixture. The specific wiring within the switch boxes can be thought of like a small network. The traveler wires act as communication lines between the switches, allowing the current to flow through different paths depending on the position of each switch. The four-way switches essentially swap the traveler wires, providing the additional switching locations. When troubleshooting issues with a multi-switch setup, there are several things to check. Firstly, ensure all connections are secure. Loose connections can cause intermittent problems or complete failure. Secondly, verify that the correct wires are connected to the correct terminals. Miswiring is a common mistake, and it can prevent the circuit from functioning. Thirdly, test the switches themselves. Switches can fail over time, so it's important to rule out a faulty switch. Fourthly, check the light bulb. It may seem obvious, but a burnt-out bulb can mimic a wiring problem. Fifthly, inspect the wiring for any signs of damage. Nicks, cuts, or frayed wires can cause shorts or open circuits. When working with electrical wiring, it's crucial to understand the basics of electrical circuits. A simple circuit consists of a power source, a load, and conductors to connect them. In the case of a light switch, the switch acts as a gate controlling the flow of electricity to the light bulb. Understanding voltage, current, and resistance is also important. Voltage is the electrical potential difference, measured in volts. Current is the flow of electrical charge, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. Ohm's law describes the relationship between these three quantities, stating that voltage equals current times resistance. When wiring switches, it is essential to adhere to the National Electrical Code, or NEC, and any local electrical codes. These codes provide guidelines for safe wiring practices, including wire sizes, box fill calculations, and grounding requirements. Always use appropriately sized conductors for the circuit. The size of the wire determines its ampacity, which is the maximum current it can safely carry. Using undersized wires can lead to overheating and fire hazards. Ensure that all metal boxes and enclosures are properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Use appropriate wire connectors for all connections. Wire connectors should be sized correctly for the number and size of the wires being joined. Avoid using tape alone to make connections, as it can loosen over time. When working in older homes, it is important to be aware of potential hazards such as asbestos and lead paint. Take appropriate precautions to protect yourself from exposure to these materials. If you are unsure about any aspect of electrical wiring, it is always best to consult a qualified electrician. Working with electricity can be dangerous, and it is important to prioritize safety. To elaborate on NEC requirements, several sections pertain to switch wiring. NEC Article 314 covers outlet boxes, conduit boxes, and fittings. This section provides requirements for the size and installation of electrical boxes. NEC Article 404 covers switches, including their installation and wiring. This section specifies the requirements for switch ratings, wiring methods, and grounding. NEC Article 310.15 details the ampacity of conductors, which is critical when selecting the correct wire size. This section provides tables and calculations to determine the appropriate wire size for different circuit types and conditions. NEC Article 250 covers grounding and bonding, which is essential for electrical safety. This section provides requirements for grounding electrodes, equipment grounding conductors, and bonding jumpers. Common mistakes when wiring switches include incorrect wire connections, loose connections, and improper grounding. Always double-check your wiring and ensure that all connections are tight and secure. Improper grounding can create a shock hazard, so it's important to follow the NEC guidelines for grounding and bonding. In summary, wiring two four-way switches in a series allows control of a light fixture from multiple locations. Always prioritize safety by turning off the power, testing for voltage, and following the NEC guidelines. Use appropriate materials and tools, and double-check all connections. If you're unsure about any aspect of electrical wiring, consult a qualified electrician. For example, let's say you have a long hallway with entrances at 3 different points. You would like to be able to turn the hallway light on or off from any of these 3 locations. You can achieve this using 2 4-way switches and 2 3-way switches. The 3-way switches would be placed at the 2 ends of the hallway, and the 2 4-way switches would be placed in between. The power source would be connected to one of the 3-way switches. The traveler wires from the 3-way switch would then be connected to the traveler terminals of the first 4-way switch. Traveler wires from the first 4-way switch would be connected to the traveler terminals of the second 4-way switch. Finally, the traveler wires from the second 4-way switch would be connected to the traveler terminals of the other 3-way switch. The load wire, which goes to the light fixture, would be connected to the common terminal of the second 3-way switch. With this configuration, you can turn the hallway light on or off from any of the 3 switch locations. Each switch changes the state of the circuit, so flipping any switch will toggle the light. It is important to note that the NEC requires all electrical work to be performed in a safe and workmanlike manner. This includes using appropriate wiring methods, properly grounding all equipment, and making secure connections. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. When selecting switches for a multi-switch circuit, it is important to choose switches that are rated for the voltage and current of the circuit. Most residential lighting circuits are 120 volts and 15 or 20 amps. The switches should be rated for at least these values. It is also important to choose switches that are compatible with the type of wiring being used. For example, if you are using non-metallic sheath cable, you should use switches that are designed for use with this type of cable. When installing switches, it is important to follow the manufacturer's instructions carefully. The instructions will provide specific information about how to connect the wires to the switch terminals. It is also important to make sure that the switches are securely mounted in the electrical box. When troubleshooting a multi-switch circuit, it is helpful to have a basic understanding of how the circuit works. The switches work together to control the flow of electricity to the light fixture. If one of the switches is not working properly, it can prevent the light from turning on or off. To troubleshoot the circuit, start by checking the light bulb. Make sure that the bulb is not burned out. If the bulb is good, check the wiring at each of the switches. Make sure that the wires are securely connected to the switch terminals. Also, check for any loose or damaged wires. If you find any problems with the wiring, repair or replace the wires as needed. If you are still having problems with the circuit, it may be necessary to replace one or more of the switches. To replace a switch, first turn off the power to the circuit. Then remove the old switch from the electrical box. Disconnect the wires from the old switch and connect them to the new switch. Make sure that the wires are securely connected to the switch terminals. Finally, mount the new switch in the electrical box. After replacing the switch, turn the power back on to the circuit and test the switch. If the switch is working properly, the light should turn on and off as expected. Also, consider smart switches. Smart switches offer a variety of advanced features, such as remote control, dimming, and energy monitoring. They can be controlled using a smartphone app or voice commands. They also offer added convenience and energy savings. Smart switches can be integrated into a home automation system, allowing you to control your lights along with other smart devices. When choosing smart switches, it is important to consider compatibility with your existing wiring and home automation system. Some smart switches require a neutral wire, while others do not. Some smart switches are compatible with certain home automation platforms such as Apple HomeKit, Google Assistant, and Amazon Alexa. Smart dimmers allow you to adjust the brightness of your lights, creating different moods and saving energy. Smart dimmers can be controlled using a smartphone app, voice commands, or a traditional dimmer switch. Occupancy sensors can automatically turn lights on and off based on whether someone is present in the room. This can save energy and provide added convenience. Timers can be used to automatically turn lights on and off at specific times. This can be useful for security purposes or for creating the illusion that someone is home when you are away. In addition to switches, there are also a variety of other lighting control devices available, such as motion sensors, photocells, and remote controls. Motion sensors can be used to automatically turn lights on when someone enters a room or area. Photocells can be used to automatically turn lights on at dusk and off at dawn. Remote controls can be used to control lights from a distance. When choosing lighting control devices, it is important to consider your specific needs and preferences. Think about how you want to use the lights and what features are most important to you. The installation of 2 4-way switches and associated wiring will typically involve running new electrical cables within walls or ceilings. This requires careful planning and execution to avoid damaging existing structures or creating safety hazards. Firstly, before running any new cables, it is crucial to map out the desired routing. Identify the locations of the existing switches, the light fixture, and the power source. Plan the path of the new cables to minimize bends and obstructions. Secondly, when running cables through walls or ceilings, it is important to use appropriate wiring methods. Non-metallic sheathed cable, or Romex, is commonly used for residential wiring. The cable should be securely fastened to studs or joists using cable staples. Thirdly, when drilling holes for the cables, be careful not to damage any existing wiring, plumbing, or HVAC systems. Use the stud finder to locate studs and joists before drilling. Avoid drilling into areas where there may be hidden wiring or pipes. Fourthly, when pulling the cables through the walls or ceilings, use a fish tape or cable puller to make the job easier. Be careful not to kink or damage the cables during the pulling process. Fifthly, after running the cables, be sure to properly terminate them at the switch boxes and light fixture. Use appropriate wire connectors to make secure connections. Label each wire to avoid confusion during the wiring process. Testing is a critical step in the process of wiring. After completing the wiring, it is essential to test the circuit to ensure that it is working properly. Firstly, before turning on the power, visually inspect all of the wiring connections. Make sure that all wires are securely connected to the switch terminals and that there are no loose or exposed wires. Secondly, use a multimeter to test the continuity of the circuit. This will verify that the wires are properly connected and that there are no shorts or open circuits. Thirdly, use a voltage tester to check for voltage at the switch terminals. This will verify that the power is being supplied to the circuit. Fourthly, after verifying the wiring and voltage, turn on the power to the circuit. Test each of the switches to make sure that they are turning the light on and off as expected. Fifthly, if any problems are found, turn off the power immediately and troubleshoot the wiring. Check for loose connections, damaged wires, or miswired switches. After correcting any problems, retest the circuit to ensure that it is working properly. As an example scenario, consider a situation where you want to control a set of recessed lights in a large living room from 3 different locations. One location is near the main entrance, another is near the seating area, and the third is near the doorway to the kitchen. To achieve this, you would use 2 4-way switches and 2 3-way switches. The 3-way switches would be placed at the main entrance and the kitchen doorway, and the 2 4-way switches would be placed in between, near the seating area. The power source would be connected to one of the 3-way switches at the main entrance. The traveler wires from the 3-way switch would then be connected to the traveler terminals of the first 4-way switch near the seating area. The traveler wires from the first 4-way switch would be connected to the traveler terminals of the second 4-way switch, also near the seating area. Finally, the traveler wires from the second 4-way switch would be connected to the traveler terminals of the other 3-way switch at the kitchen doorway. The load wire, which goes to the recessed lights, would be connected to the common terminal of the 3-way switch at the kitchen doorway. With this configuration, you can turn the recessed lights on or off from any of the 3 switch locations. This provides convenient control of the lighting from multiple points in the living room. Always consult the National Electric Code, or NEC, for all wiring projects. Here are some specific examples of NEC requirements that are relevant to wiring 2 4-way switches in a series. NEC Section 300.11 requires that wiring be securely supported. This means that the cables must be fastened to studs, joists, or other structural members using cable staples or other approved methods. NEC Section 314.16 specifies the minimum size of electrical boxes. The box must be large enough to accommodate the wires, devices, and connectors without overcrowding. NEC Section 404.2 requires that switches be rated for the voltage and current of the circuit. The switches must be marked with their voltage and current rating. NEC Section 250.148 requires that all metal boxes be grounded. The grounding conductor must be connected to the box using a grounding screw or other approved method. Following these NEC requirements will help ensure that the wiring is safe and compliant with electrical codes. Ignoring these requirements can create safety hazards and may result in fines or other penalties. Here is a more detailed look at the individual tasks involved. When you are ready to identify the power source, this will involve locating the circuit breaker that controls the circuit you will be working on. Turn off the breaker and test the wires to make sure that they are not live. Locate the incoming power wire, also known as the line wire, and determine which switch location will be connected to it. Then, connecting the line wire means connecting the line wire to the line terminal on the designated switch. This terminal is typically labeled line or common. Use a wire connector to make a secure connection. Next, connecting the traveler wires requires that you connect one traveler wire from the power source switch to the traveler 1 terminal on the first 4-way switch. Connect the other traveler wire from the power source switch to the traveler 1 terminal on the second 4-way switch. These terminals are typically labeled traveler 1 and traveler 2. Again, use wire connectors to make secure connections. The next step, connect the remaining traveler wires, means that you must connect the remaining traveler wire from the first 4-way switch to the traveler 2 terminal on the second 4-way switch. Connect the remaining traveler wire from the second 4-way switch to the line terminal on the 3-way switch, if one is being used. Next, connect the load wire to the load wire terminal on the light fixture. This terminal is typically labeled load or common. Once again, use a wire connector to make a secure connection. When you secure the connections, this means that you must carefully inspect all of the wire connections. Make sure that all of the wires are securely connected to the switch terminals and to the wire connectors. There should be no loose or exposed wires. Wrap each connection with electrical tape for added insulation and protection. Finally, carefully push the wires back into the electrical box and mount the switch securely. Replacing the switch is also an important skill to understand. Firstly, turn off the power to the circuit at the circuit breaker. Secondly, remove the faceplate from the switch. Thirdly, unscrew the switch from the electrical box. Fourthly, carefully pull the switch out of the box. Fifthly, disconnect the wires from the old switch. Sixthly, connect the wires to the new switch. Seventhly, push the switch back into the electrical box. Eighthly, screw the switch back into the box. Ninthly, replace the faceplate. Tenthly, turn the power back on at the circuit breaker.